Okay, so we're continuing on with Unit 8, and we're going to look at our second lesson today, and that's solving exponential equations. I'm hoping that you'll like these because the biggest trick to these is making sure you have the same base, and once you do, you're setting the exponents equal to each other and solving it just like an equation. All right, so our objective says to solve exponential equations. An exponential equation is an equation in which a variable appears in the exponent. Remember, variables x, y, a, b, those are all variables. What are the steps we will use to solve the exponential equations? First, we're going to rewrite the problem using the same base. Once the bases are the same, you can drop the base and set the exponents equal to each other, and then you're going to be solving it as a multi-step equation. So let's look at a few examples and see what I mean by this. In number 1, we have 2 to the x minus 16 equals 2 to the 5th power. All right, so it says rewrite the problem using the same base. So we're lucky. These are our bases. The base is always whatever's not the exponent, okay? So we already have that using the same base. Once the bases are the same, you drop the bases and you set the exponents equal to each other. So I get x minus 16 equals 5. And then how do I get x by itself? I add 16, and I get x equals 21. And that's all we have to do. So basically it's saying if I put in 21 for x, so that'd be 21 minus 16, and that would give me 2 to the 5th equals 2 to the 5th, and that's true. All right, let's go to another one. 9 to the 2x minus 5 power equals 27. Okay, so the first thing we have to look at, are our bases the same? No, absolutely not. One's a 9, the other one's a 27. So we have to think about exponents again and how we can write 9 differently. For example, we know that 3 times 3 is 9, so we can write this as 3 to the 2nd power. And that's great, but when we do that, we also have to continue to have the exponent that was already there with it. So we have 3 to the 2nd power has replaced 9, but we still have the 2x minus 5 there. Equals, what about 27? Can 27 be written as a base of 3? You maybe need to use your perfect square, cube, 4th root, 5th root chart to help you. Because if you look at that chart, you'll see that 3 to the 3rd power is 27. Okay, now we have the same base. We drop the base and we set the exponents equal to each other. So this is 2 times 2x minus 5 equals 3. Okay, now let's distribute. 2 times 2x is 4x. 2 times negative 5 is negative 10 equals 3. We're going to solve. How do we solve? We're going to add 10. We get 4x equals 13, and we're going to divide by 4. And we're going to x equals 13 fourths. So what it's saying is that if we went ahead and plugged in 13 fourths to the x, that it would make this equal to each other. Okay, you can always go and check them. I'm not asking you to do that, but feel free to do it if you'd like. All right, 4 to the 3x plus 5 power equals 8 to the 4x minus 3 power. Again, I have to have the same base. I don't. Don't get confused and say 4 squared is 8 because you're not doing 4 times 2. Remember, these are powers when you do it. So we have to think about perfect squares. And if we think about 4, we know that 2 squared is 4. So we can rewrite 4 as 2 squared, but don't forget, you're bringing down the 3x plus 5. Okay, what about 8? Can we write 8 with a base of 2? We can. 2 to the 3rd power. Don't forget, you still have your 4x minus 3 there. Now, same base, same base. What do? We drop the base. What do we have left? 2 times 3x plus 5 equals 3 times 4x minus 3. That's a 4 there. Okay, so now distribute and get 6x plus 10 equals 12x minus 9. Let's get our numbers together. Let's subtract our 6x, and then let's add our 9. And when we do, we get 10 plus 9 is 19. 12 minus 6 is 6x. The 9s are gone. Divide by 6. So you'll notice some of these aren't coming out as integer answers. They're rational numbers, and that's okay. And you can just leave them as improper fractions. Don't turn them into mixed numbers. Just leave them improper. Okay, let's look at another one. Let's look at this one. This one's kind of interesting. Number 4. Number 4 is 5 to the x power equals the square root of 125. Okay. All right, so let's think about how we're going to do this one. This one has a little bit to it. First, we want to take it out of radical form, which is exactly what we just did in this last unit, and last section, and turn it into exponential form. Well, how do we convert that? The square root of 125 is equivalent to 125 to the 1/2 power, because remember that's a square root. And this is still 5 to the x. So 5 to the x equals 125. How can we write 125 with a base of 5? We can. If we look at that chart you have, 5 to the 3rd power is 125. We still have to bring down the 1/2. When we multiply 3 times 1/2, we get 3/2. So this is 5 to the x power equals 5 to the 3/2 power. To solve, same base, we drop our base. We drop our base, and this becomes x equals 3/2. And you're done with that one. All right. We have time for a few more. The next one, 10 to the x minus 1 power equals 100 to the 4 minus x. We have a base of 10 and we have a base of 100. We can rewrite 100 so it has a base of 10. How? Well, 10 squared. And don't forget, the 4 minus x has to come down. Base of 10, so that's x minus 1. Now, same base. We drop the base, we keep the exponents. All right, so if x minus 1 equals 2 times the difference of 4 and x, let's distribute on the right, so we get 2 times 4 is 8. 2 times negative x is negative 2x, so if x minus 1 equals 8 minus 2x, let's add 2x, and let's add 1. 1x plus 2x is 3x, negative 1 plus 1 is gone, 8 plus 1 is 9, and 2 minus 2. So this becomes x equals 3. Again, you can plug all these in, and you can test them out. Okay. Normally I would have you try the next 3 on your own and come back and check your answers. So I'm going to write them and then just ask you to pause for a minute and then check them and see how you did. Okay, so let's try these 3. Well, that's not really number 1. Let's call that number 6. Number 6 is 8. That's the base to the 2 plus x equals 2. Number 7 is 3 to the negative, and in parentheses, x plus 5 equals 9 to the 4x. And then the last one I want you to try is 27 to the 2x minus 1 equals 3. All right, let's just stop. Let's just stop for a minute and then we'll come back and check these. Okay, so hopefully you took a few minutes to stop. I'm sure it continued with myself recording, but let's look at these. Number 6. 8 to the 2 plus x power equals 2. Well, let's talk about the equals 2. If there's no exponent there, what do we know that is there? What is understood to be there? A 1. Okay, so that's helpful to know that there is an exponent there. It's not just 0. Now let's talk about our bases. We have a base 8 and a base 2. What do we know about 8? Can we get 8 to be the base 2? Yes. 2 to the what power? Well, 2 to the third. But the 2 plus x still has to come down. Equals 2 to the first power. Once we have the same base, the bases go away. And we write 3 times. The sum of 2 and x equals 1. We can distribute and get 6 plus 3x equals 1. We can subtract 6 and divide by 3. Oh, that's a negative 5. And we get x equals negative 5/3. All right, let's look at number 7. 3 to the negative x plus 5 power equals 9 to the 4x power. Again, we have a base of 3 and a base of 9. Can we get 9 to be a base of 3? We sure can. 3 squared is 9, but we have to bring down the 4x. On the left side, we have 3 to the negative x plus 5 power. Now that we have the same base, we get rid of them. We have a negative x plus 5 equals 2 times 4x, which we can write that as 8x. Now, why did I specifically leave that negative there in front? Because I wanted to make sure you knew on the left that you have to share that negative. That's like a negative 1x minus 5 equals 8x. Now we're going to add 1x. Negative 5 equals 9x. Divide by 9. So negative 5/9 equals x. Again, if we put that in for x and solve, it would make it true. Our last one, 27 to the 2x minus 1 equals 3. We got to look at our bases. We have 3 and 27. Can 27 be written as a base of 3? It can. 3 to the third power times, don't forget to bring down the 2x minus 1. What do we notice when there's no exponent there? That was a 1. So this becomes 3 to the first power. Same base, same base. We get rid of our base, and we keep just our exponents. We share our 3 on the left. We get 6x minus 3 equals 1. We're going to add 3 and add 3 to both sides. 6x equals 4. So we divide by 6. X equals 2/3. X equals 2/3. Okay. So we did quite a few. We did 8 practice problems. Hopefully you're making sense of it and you're understanding it. Again, the key might be to use your perfect square, cube, 4th root, 5th root chart to help you with these, because the goal is to get your base to be the same, and doing that is creating some form of exponents. As always, if you need help, please reach out to me. I love, some of you already have, and I get to work with you on Teams, and it's so much easier to explain it, and I think it's been helpful for students that have done that. So please do reach out to me if you need help. Once you feel confident with this and have these down, please feel free to work on the homework. Okay, y'all have a great day.